Hi, today we're going to talk about Karl Fischer, specifically the Aquapal, and we're going to talk about using specific gravity to take measurements versus the traditional way, or in many cases using weight. At the end, we're going to talk about specific gravity in general and why we use it. Okay, so here we have the Aquapal, and the Aquapal has a keypad on top. It's a very basic keypad. Looking at the keypad, we have some basic function keys, and in particular, anytime you run a test, you tell the Aquapal some instructions as to how you're going to run the test. Specifically, there's a ppm button if you want your results in parts per million. There's a percent if you'd rather have it in percent, and those are the two types of measurements you're going to set it for, whether it's percent or ppm. In addition to that, you're going to choose whether you're going to use weight or specific gravity. There's an additional key, but that's for diluted samples, and we don't really work with that one very often. But the two that are popular are the weight and the specific gravity. So what we're going to do, and I talk about this because we get a lot of questions about how do you set it up, how do you run tests. In the manual, we do have step-by-step instructions as to how you go about doing it, and we're going to do it right here in front of you so you can see how to do it for yourself. I think one of the big questions that people have is, do we have to enter every time we run a test? Do we have to enter ppm or percent? And do we have to tell it its specific gravity? And do we have to put in the volume and so forth? And what I'm going to show you today is a pro tip. What we're going to show you is that you don't have to enter the data every time, and simply once you input that data into the Aquapal, you can then just come up and run a test every time and just by pressing the start button. So let's go ahead and do that. Okay, so we're going to actually run a test, and so here we go. So what we do on our first test, we're going to press ppm to tell it we want our result in ppm. We're going to press the V over SG button, and that is so that we're telling it that we're going to use specific gravity and volume. So the first thing it's going to ask for is our volume, and I'm going to do 1 mil. So I'm going to press 1 and press enter. And then it's going to prompt me for the specific gravity. And so at that, petroleum generally is 0.86, so I'm going to enter 0.86 and press the enter button. Now the instrument's ready to go. And the way the instrument works is there's a natural delay before the test. So what we're going to do is we're going to take our sample in the syringe. I'm not really going to do a mil because I just want to show you guys how it works. But so I'm going to go ahead and I'm going to press the start button, and then it starts the delay, and then I'm going to press some sample in here. And then it's going to measure. Okay, so the test has been running, and it's winding down to the end point. And when it's finished, it automatically prints out the results. So no need to enter a weight. It knows the volume, it knows the specific gravity, and it prints out your result. Now, here's the key. So we're ready for another test. Do I need to enter any other additional information, ppm and Vs over G? No, I don't. All I need to do is press the start button and inject my sample. And I have 6-second delay to inject the sample. So what I typically would do is I'll get my needle ready, and then I'll press the start button, and then I'll inject my sample, and the second test is now underway. So again, all you have to do once you set the parameters up is press the start button and inject your sample. No need to re-enter those. You could even shut the instrument off and turn it back on and do the same thing, press the start button, because once you enter those into memory, they stay there. You don't have to have the power on for it to save that in memory. So that's an example of how easy this is to use. And I wanted to go into a little bit further discussion as to why would we want to use specific gravity, or why do some organizations use specific gravity. And weight is the preferred method for getting really accurate results. We weigh our sample on a 4-place balance. We enter the beginning weight and the ending weight, and that's usually how a lot of people do it. However, if you're in an environment where you don't have a place for an analytical balance, specific gravity is a great alternative. So what is specific gravity? Well, specific gravity is another way for us to find weight. It's based on density. If we think about water, specific gravity of water at 4 degrees C is, at that point, 1 milliliter of a sample is equal to 1 gram by weight. So if you have a specific gravity of, say, 0.86, logic or the math behind it, basically you're getting a weight of a volume, and in this case 0.86 grams. And so it's kind of a way of getting a weight of something using a volume rather than a weight or balanced. So a lot of organizations use specific gravity because it's one less instrument that they have to have. It's pretty straightforward. The pros and cons, you need to have a good syringe, something where you're confident that you're actually getting 1 mil in there, because again, it's based on the volume, and we're really eyeballing that volume. It's really what we see. There's no way to measure it other than to visualize that 1 mil is there. Obviously, if it's a 1 mil syringe, yes, but you have some in the syringe, you could have some in the headspace of the syringe. So getting the right volume is important. Test just finished. And knowing the specific gravity, in this case, that's the other piece of information. So if you have those two, you're able to do this very efficiently. I hope this has been helpful. If you have any questions, please let me know. Just email us at info@scientificgear.com or call our toll-free number, and we'll be able to help you out. Thank you.